Hello everyone, I Ashish Kumar Chetri, bearing roll number 20 NS0322, Department of Physics, under Sikkim University. Today I am going to present a short presentation on the topic spray pyrolysis, which carries 25 marks for term paper. It is an immense pleasure for me to express gratitude towards the people who helped the most throughout my presentation. I convey my sincere thanks to the Dr. Deepak Tiwari, Principal Sir, and Sir Sabat Rai, HOD Physics, and Supervisor Dr. C.P. Khatiwada and my mates for their valuable academic support, which are highly helpful to me to complete my presentation. So I am going to start with the introduction of spray pyrolysis. The spray pyrolysis is a wonderful method in material science, a simple and inexpensive method of preparing thin and thick films. Spray pyrolysis is a thermally stimulated reaction. The main components of spray pyrolysis equipment are an atomizer, precursor solution, substrate, heater, and a temperature controller. The atomizer may be an air blast in which liquid is exposed to a stream of air or ultrasonic frequencies which produce short wavelengths, or electrostatics in which liquid is exposed to a high electric field. In spray pyrolysis, the aqueous solution containing soluble salts of the ingredient atoms of the needed component is sprayed onto the heated surface of the substrate, in which endothermic decomposition takes place and results a single crystallite or a cluster of crystallites of the necessary compound is formed. Initially, the necessary chemical reactants are selected carefully so that when they in solution form are sprayed on heated surface, the other undesired chemical products and the excess solvent should be volatile at the temperature of deposition. The thermal energy needed for the thermal decomposition and also the recombination of the species taking part in the combination after sintering and recrystallization of the crystal clusters is supplied by the heated surface. Here is the diagram of spray pyrolysis technique, and now I am going to describe spray pyrolysis technique equipments. It consists of mainly spray nozzle, rotor for spray nozzle, liquid level monitor, hot plate, gas regulator valve, airtight metallic chamber, substrates. Now I am going to describe about its equipment in briefly. Number 1, spray nozzle. It is made up of glass and consists of the inner solution tube surrounded by the gas tube through which carrier gas flows. With the application of pressure to the carrier gas, a vacuum is created at the tip of the nozzle and the solution is automatically sucked and the spray starts. Now another equipment is rotor for spray nozzle. It is an electric car wiper and it's used to rotate the spray nozzle along with a speed controller. Number C, liquid level monitor. The spray rate at a fixed pressure depends on the height of solution measured with reference to the tip of nozzle, and the arrangement for the change in height of the solution forms liquid level monitor. Now hot plate. The iron disc with diameter 16 cm and thickness 0.7 cm was supported on the electric heater. Maximum temperature up to 600 degrees Celsius can be obtained with this arrangement. Now, gas regulator valve. The gas regulator valve was used to control the pressure of the gas. A coming glass tube of length 25 cm and a diameter of 1.5 cm were converted into a gas flow meter. Now another is airtight metallic chamber. Since number of toxic gases is evolved during the spray, it is necessary to fix the spraying unit in an airtight metallic chamber. Now last one is substrate. The substrate is made of quartz or silica SiO2 material. It is chosen as substrate and is act as a plate. So it is called quartz plate. Substrate is a passive component in the device and is required to be mechanically stable, matching thermal expansion coefficient with deposit layers and inert during the device fabrication. Now I am going to explain about the spray pyrolysis technique. The spray pyrolysis means the decomposition of chemical compounds or solution under the action of heat at very high temperature. Actually, pyrolysis word is originated from pyro means heat and lysis means breaking. Thus, pyrolysis means change under the action of heat. The breaking part of complex molecule into simple unit by the use of heat is called pyrolysis. It possesses many advantages such as low processing temperature, high homogeneity and purity of products and so on. The chemical spray pyrolysis technique has been throughout the last 3 decades one amongst the most important techniques to deposit a large type of materials in thin film. The pyrolysis is a particular type of CVD that takes place by thermal decomposition of volatile components on the substrate. In the thermal decomposition, the substrate is normally heated above the decomposition temperature and reactant gases flow over the hot substrate. Decomposition into films or coatings. The spray process involves spraying of solution or natural oils or carbon precursor as a oil of various constituents atom of desired components elements on the heated substrates that is maintained at elevated temperature. The spray of very fine droplets of solution filled in the spray gun is achieved by the spray nozzle with the help of carrier gas. In short, spray pyrolysis needs the following steps. That is, transforming liquid precursor or solution of precursor into micro-sized droplets and making solvent to evaporate and allowing solute to condense and making the solute to decompose and react and last one centering the solid particles and there are many types of spray pyrolysis techniques. Number 1, electrostatic spray pyrolysis, corona spray pyrolysis, microprocessor based spray pyrolysis, ultrasonic nebulizer atomization, and improved spray hydrolysis. Now I am going to explain about the formation of thin films droplets during spray pyrolysis technique process. Uh, In spray pyrolysis, precursor solution is atomized through a nozzle. The nozzle converts the solution into small droplets known as aerosols. The aerosols are allowed to incident onto the preheated substrates. The paralytic decomposition of the aerosols depends on the substrate temperature. The formation of thin films with desired properties are possible only at optimum substrate temperature. Various steps during pyrolysis of aerosols are: Number 1. In first step, an aqueous precursor solution is converted into aerosols by spray nozzle. Number 2. Solvent evaporation takes place in second step. In the third step, vaporization of the solvent leads to precipitate formation as the droplets approaches the substrate. And number 4. Pyrolysis of the precipitate occurs in succession before the precipitate reaches the substrate. This constitutes step 4. And in step 5, when the precipitate reaches the substrate, nucleation and growth of metal oxide thin films. And finally, in sixth step, growth of the nuclei leads to the formation of continuous thin layer of metal oxide. So this was the steps of formation of thin film droplets. Now comes factor governing spray pyrolysis technique. The number of factors governing the thin film formation mechanism depends on: Number 1, the atomization of the spray solution into a spray of fine droplets, which depends on the geometry of the spraying nozzle and pressure of carrier gas. Number 2, the properties of the thin films depend upon the anion to cation ratio, spray rate, substrate temperature, ambient atmosphere, carrier gas, droplet size, and also on the cooling rate after deposition. Number 3, the thin thickness depends on the distance between the nozzle and substrate. Number 4, the thin formation depends upon the process of droplet landing, reaction and solvent evaporation, which are related to droplet size and its moment. An ideal deposition condition is that when a droplet approaches the substrate just as the solvent is completely removed. Now substrate cleaning. Uh, Substrate cleaning process involves the following methods. Number 1, the substrates were washed with detergent solution, labolin, and then with water. And number 2, these substrates were boiled in chromic acid for 5 minutes. And number 3, substrates were cleaned with double distilled water. This substrate were kept in NaOH solution to remove acidic contamination. And the substrate were again washed with distilled water and cleaned ultrasonically. Finally, substrate dried in alcohol vapors. Advantages of spray pyrolysis. It is spherical morphology, narrow particle size distribution, easy preparation of powder with complex formation, relatively homogeneous composition. Now limitations. This technique is quite empirical with a number of variables that can affect the final product, like solute concentration, atomization technique, temperature gradient, residence time in furnace, carrier gases, and so on. So this was my presentation. Thank you.